Once again, welcome back our YouTube channel Solve with RK. First of all, I would like to thank you so much for joining this video. So today we're discussing about find the limit. So limit of this sequence. So the problem is the 1 by n into 2n plus 1 into 2n plus 2 etc. 2n plus n, so whole power 1 by n. So blindly we apply the theorem Cauchy's second limit theorem. So already we know that Cauchy's second limit theorem. So the theorem says first of all we have to find limit tends to infinity, so an plus 1 divided by an. So this limit is exist, that limit is also equal to the given problem, that's all. So first of all we have to find this limit of this sequence. So let's go for the solution. So first we take an. So here an is equal to 2n plus 1 into 2n plus 2, so into etc. So 2n plus n, so whole divided by n power n. So next we have to find an plus 1. Just we simply apply n equal to n plus 1. Therefore we get 2n plus 3. So here also 2n plus 4, so up to etc. So here also 2 into n plus 1 in plus n plus 1, so whole divided by n plus 1 whole power n plus 1. So the just to simplify this term, so 2n plus 3 into 2n plus 4, so up to etc. So here also 2n and 2, so therefore 3n, so 3n plus 3, so whole divided by n plus 1 whole power n plus 1. So next we have to find an plus 1 divided by an. So first an plus 1, so an plus 1 is equal to 2n plus 3 into 2n plus 4, so up to etc. So 3n, so 3n plus 1, 3n plus 2, so 3n plus 3, so whole divided by, so here also n plus 1, so whole power n plus 1. So into an, so an which means n power n, so whole divided by so 2n plus 1 into 2n plus 2 into 2n plus 3, so up to etc. last 3n, because 2n plus n which is equal to 3n, so therefore we simply write 3n. So next we cancel the common term, so therefore 2n plus 3, so here also 2n plus 3, so 2n plus 4, here also 2n plus 4, up to 3n, so up to 3n. So therefore remaining terms are, so therefore the remaining terms which is equal to, so 3n plus 1 into 3n plus 2 into 3n plus 3, so into n power n, so whole divided by, in denominator, so remaining term n plus 1 whole power n plus 1, so into 2n plus 1 into 2n plus 2. So just we simply take in n in each term from outside, so therefore we get here n, so here also n, so therefore we get n cube. So the remaining term 3 plus 1 by n, so 3 plus 2 by n and also 3 plus 3 by n, so here also n power n, so whole divided by, so in denominator we take n outside, so therefore we get n plus 1, so whole power n plus 1, so here also n square, so therefore we get 2 plus 1 by n, so 2 plus 2 by n, so here also n cube, so here n square, therefore n square get cancelled, so remaining term which means here also n power n, therefore we get n power n plus 1 into 3 plus 1 by n, so 3 plus 2 by n, so 3 plus 3 by n, so whole divided by n plus 1 whole power n plus 1, so into 2 plus 1 by n, so 2 plus 2 by n. So therefore which is equal to, so n divided by, so n plus 1, so whole power n plus 1, so 3 plus 1 by n, so into 3 plus 2 by n into 3 plus 3 by n, so whole divided by, so remaining 2 plus 1 by n, so into 2 plus 2 by n. So this is the an plus 1 divided by an. So next we want to find limit tends to infinity, so therefore we apply the limit on both sides. So we get, so here also tends to 0, so here also tends to 0, so here also tends to 0, so here tends to 0, so here tends to 0, so this is also tends to 1 by e. So already we know that, so limit, so n tends to infinity, so n divided by n plus 1, so whole power n is equal to 1 by e. So just we apply this limit on the here, so therefore we get, so 1 by e into, so 3 into 3 into 3, so divided by 2 into 2, so therefore which is equal to, so 27 by 4 into e. So this is the limit n tends to infinity, so a n plus 1 divided by a n. So just we apply the Cauchy second limit theorem. So Cauchy second limit theorem, this limit is also which is equal to, so the given sum, so therefore this sequence limit which is equal to 27 divided by 4 into e. So this is the answer for this sum. So thank you so much.